So if you weren't completely sure on what we did in class today, this video is just going to kind of recap how you find a normal probability using a z-score. You're going to want to have your graphing calculator nearby if you're following along, because there's a command in the calculator that you're going to need to do to find the answer. Okay, so as I'm looking at this, I see it tells me we're talking about the length of life of an instrument. It's a normal distribution with a mean of 12 months and a standard deviation of 2 months. Okay, so what I'm going to do right away is I'm going to label those. Mean 12 and the standard deviation is 2. Okay? So the first thing I'm going to do is I'm going to find my z-score for the amount that they're talking about. So in this case, in part A, they're saying find the probability that an instrument produced by this machine will last less than 7 months. So 7 is my x. So my z-score formula, if you remember, is x minus the mean divided by the standard deviation. So I'm going to fill in my values. 7 minus 12 divided by 2. And remember, we're rounding that to 2 decimals. So I get negative 2.5. Okay, now I want to draw a picture of what they're asking me for. So I'm going to just draw a little bell curve, and I'm going to label my z-score. So if I know the mean is 0 right in the middle on this curve, then negative 2.5 should be to the left. So I'm going to mark off somewhere around here, negative 2.5. You don't have to mark the middle, but sometimes it's helpful. And since they're talking about less than 7 months, I'm going to mark that and shade to the left. So this should be a pretty small probability because it's a very small part of the left tail of the curve. So there's my picture to correspond to what I'm finding. And now this last part is going to be where I go and actually find the probability in my calculator. So we do want to use proper notation. So I'm finding the probability that my value is less than 7. So I'm going to set it up like that. I am going to also write out my calculator step, which I'll guide you through in a second. So you're going to be going to normal CDF. Since I'm finding a value less than, that means I'm taking an arbitrarily large number, which we're just going to use negative 100. I should say an arbitrarily large small number. And I'm going up to negative 2.5. Okay, so if you have your calculator nearby, you're going to press second vars. And choice 2 should be normal CDF, and then you're going to type exactly what we just wrote. And I didn't mention this, but why don't we go ahead and round our probabilities to 3 decimals. So I get that this is 0.006, which, as we expected, is pretty small. So that is my final answer. That would be a model way to show all of your work, showing your z-score calculation, showing your curve, and then finally showing your probability with proper notation. Let's try another one. Okay, we're going to be using the exact same data for all 3 of these examples, so I'll just write out again. My mean is 12, my standard deviation is 2. Okay, so this time I'm finding the probability that an instrument produced by this machine will last between 9 and 12 months. This means I actually have 2 x values here. So 9, I'll call him x1, and 12, I'll call x2. So the only thing that's really going to change here is I'm going to have to calculate 2 z-scores. So why don't we go ahead and do that? I'll call it z1. So I'll take my x1, that's 9. Subtract my mean of 12, divide by 2. Remember, we're rounding to 2 decimals. And I get negative 1.5. I'll find my other z-score, z2. I'll take x2, which is 12, minus 12 over 2. Well, I can tell this is going to give me 0 because I'm going to get 0 on top. Okay, so now I sketch my curve. And I'm marking this time both z-scores in order, of course. So the negative 1.5 would be below the 0, and the 0 should be right smack in the middle. So if I shade that region, this is the probability that I'm trying to find. Okay, so finally I'm going to do my probability notation. So the probability that the values are between 9 and 12, so I would write this like this, 9 less than x less than 12. And so now when I do my normal CDF, I don't have any 100 anywhere because I have 2 z-scores. So I'm doing normal CDF of my smaller z-score up to my larger z-score. And I'm going to round that value to 3 decimals. So remember, press second vars, choice 2 for normal CDF. And to 3 decimals, I got 0.433. And so that's my final answer. Okay, we'll look at one more example. Same data, so I still have a mean of 12. and a standard deviation of 2. So I read through this, find the probability that an instrument produced by this machine will last more than 15. So there's my x. I only have one of them this time. So let's start by finding my z-score. So 15 minus 12 over 2. It's going to give me 1.5 to 2 decimals. I'm going to draw my curve. So since it's more than 15 months, I'm shading to the right this time. So this is 0, 1.5 is somewhere over here. So this is a little area that I need to find. And so now I do my probability. The probability of x being more than 15 months. And I'm right at my calculator command. So I'm going this time starting at my z-score up to 100 because I want the right end of it. Okay, so go ahead and put that in your calculator. Into 3 decimals, I get 0.067. And that's it. So those are 3 examples of using z-scores to find normal probabilities, an example of doing one that's a less than, a between, and a greater than, which are the 3 types that you could see.